Welcome to the hobby world of Dr. Mike. Today we're going to talk about the motor cam assembly in the electromechanical logic board. And I'll need to be able to emulate that motor cam assembly when I convert the main logic board from electromechanical relay to microprocessor. The motor cam is the pulse of the logic throughout this machine. So let's get started. Here's the motor cam assembly. The motor is in here and it drives these cams, which then operate the contacts and again provide the pulse for the logic in this machine. As you can see, when I initiate it, the switches will move with the cam, and we'll talk about the flash that you see when we talk about the output drivers. Timing is critical on the electromechanical machines, and the heartbeat of the timing is the motor cam mechanism. I've got 8 channels on my oscilloscope, so I thought I'd plug them in and see what the timing is on this motor cam assembly. We've got the index cam. I tied cams 2 and 3 together and monitoring those with one channel on my scope. 3 through 6 are monitored separately, and then I've got 2 impulse cams being monitored on the last 2 channels. Let's go over the schematic real quick. Every time there's a little bubble here in the schematic, that is a contact out of the motor cam, making sure that timing is right. Here we've got a good example of how the timing will help us out. If you've got 4 players playing and they all hit the match, you can't step up the credits all at one time. Each player needs to take its turn. So we've got cam 2, which hits the first player match first. Then cam 3 hits the second player's match. Then cam 4 hits the third player's match. And cam 5 hits the fourth player's match. So timing is critical so that all the players get a chance to get their match. I downloaded data from the scope and printed it using Matlab. You can see it here. These are your 60 Hertz sine wave. You can see the timing here, that every time a cam is operated, it's actuated for about 3 60 Hertz cycles or 50 milliseconds. Cams 1, 2, 3, 4, and 5 all are correlated with the impulse cam 2. Impulse cam 1 is offset a little bit. The time between impulse cam 1 and impulse cam 2 is about 2 to 3 60 Hertz cycles. Of the downloaded scope data for the emulated motor cam assembly. As you can see, cams 1, 2, 3, 4, and 5 line up very well with the second impulse cam. The first and the second impulse cams are separated by 34 milliseconds. The timing looks really good here.